Okay, section 4.4, modeling with volumes of revolution. So just real life applications to find the volumes of revolution. So here's example 4. You've got this diagram that shows a model of a goldfish bowl. The cross section of the model is described by the curve with the equations x equals to 2 sine t and y equals to 2 cos t plus 2, and the range of values of t is given over here, and the units are measured in centimeters. The goldfish bowl is formed by rotating this curve about the y-axis to form a solid of revolution, and we have to find the volume of the revolution. So we're going to rotate it around the y-axis. So we're going to use the formula for the finding volumes of revolution around the y-axis. So it's pi times the integral of x squared dx, but because it's parametric integration, it's going to be x squared x squared dy. Normally now it's x squared dy dt dt, and here it's going to be, let's say, t1 t2, where these are the limits. So if I pick that side of my curve as my the part that's going to be rotated, I need to find what t1 is and t2. So let's go ahead and do that first. So let's find the limits. So the bottom limit, t1, that's going to be happening when x is equal to 0 and y is equal to 0 as well. So x is equal to 0, that gives me 2 sine t is equal to 0. So sine t is 0 for t equal to 0 and pi. Obviously 0 is outside, so it's got to be pi. So t1 will be pi. Let's just check whether that is confirmed by substituting pi into the y coordinate. You'll get 2 times -1, because cos pi is -1 plus 2. That will give me 0 as well, so that is fine. To find t2, we are going to make x equal, we don't know what x is. We know that y is equal to 3, because we know that x is equal to 4. This is not a very good drawing for that value, possibly not for this one. So we've got to solve this mini equation. 2 cos t plus 2 is equal to 3. So cos t is equal to 1 over 2. That means t is equal to pi over 3. And then the other t would be 2 pi minus pi over 3. So 5 pi over 3 as well. So let's just double check. If I put 5 pi over 3 into this one, the x value, that would give me the negative value. Okay, so since I've highlighted my t2 over here, let's just check. If I put t equals pi over 3 into this, that gives me sine pi over 3, which is then root 3 over 2 times 2 is root 3, so that's positive. So that's definitely in the first quadrant. So pi over 3 is our t2. There you go. So that is going to be over here. The other one that we found, which is 5 pi over 3, would be at that point here. So but I've selected this section. Okay, so let's just multiply x squared by y differentiated. Let's just differentiate y, which gives me -2 sine t. Okay, so that will go to pi. The lower limit, I will start putting my limit pi over 3. X squared gives me 8 sine squared, not 8, x squared gives me 4 sine squared t, and dy dx gives me minus 2 sine t dt. So I've got minus 8 pi to pi over 3, and it's sine cubed t dt. So we need to integrate sine cubed. If you want to get rid of that minus, you can flip the limits if you prefer. So the lower in value limit is at the bottom and the higher in value limit at the top. So remember, to integrate sine cubed, the trick here is to split sine cubed into sine t times sine squared, which is 1 minus cos squared t. Okay, and then we can use substitution. So let's substitute it for cos t, and then du dt is equal to minus sine t. So du is equal to minus sine t dt. So minus du replaces sine t times dt, which I have got over here. So sine t times dt, that's going to give me minus du. And then you've got 1 minus u squared. There you go. So altogether, I will have, that's minus 1. So it's going to give me u squared minus 1. That's right. Du. Okay. That gives me a third of u cubed minus u, which is a third cos cubed t minus cos t. Okay, so 8 pi, a third cos cubed t minus cos t between pi over 3 and pi. Okay, so putting pi into the first cos t, that gives me minus 1. So it's minus a third, and minus 1, so it's plus 1. Putting pi over 3 into this one, it gives me a half cubed, which is an eighth, 1 over 24 minus a half. Okay, so you can just pop it into the calculator, which I haven't got handy. So that's 2/3, and this is going to be times 12 times 12. So we have 2/3 minus, and you're going to have minus 11/24, so plus 11/24, which gives me times this one by 8. 16 add 11 is going to be 27 over 24 times 8, so it's 27 over 3, which is 9 pi. That's a nice number. So the volume is 9 pi centimeters cubed. So this is part A. Moving on to part B, we've been now told to interpret this answer so it's like a model. The real goldfish bowl has a maximum diameter of 48 centimeters, and then we have to find the volume that goes with that. So what is the maximum diameter? Well, of the model, it's 4 centimeters. Okay, So in part B, in the model, the diameter is 4 centimeters. In the real fish bowl, it's 48 centimeters. So you can see that scale factor is going to be 48 divided by 4, which is 12. Okay, the volume is going to be 9 pi times scale factor cubed, because there's 3 dimensions. So 9 pi times 12 cubed, which is 48,900 centimeters cubed. Do 3 significant figures. Great. Okay, so this concludes chapter 4, and then you've got exercise 4D and the mixed exercise to follow.